All right, so I'm going to introduce you today to EasyBuild, an open source tool to deal with scientific software installation. So to kick things off, let me briefly introduce myself. So I did my computer science studies at Ghent University in Belgium. And then I started working in the HPC team in 2010. So I've been at the university for, well, 15 years now. Back when I was doing my PhD, there was basically no central HPC infrastructure at the university. That was started 2008, 2009. And then when I finished my PhD and I was one of the pilot users of their first setup and so on, I just rolled into the HPC team, which is a part of the central IT department. And I slowly became responsible for user support because I was on the other end when it all started, and then training, software installations, and so on. So EasyBuild was already there in the team, not in the state it was now, but it slowly became our responsibility to maintain it, further develop it. And then when it was pushed outside, I also became the lead developer and the release manager. My contact details are there. I'm on Twitter. You can find me on GitHub. I hang out on IRC all the time, so I'm not hard to reach. So our team in a nutshell, so we're part of the central IT department at Ghent University. So we cater to the whole university, not a specific research domain, but anything in terms of research going on at university, from astronomy through zoology. We have everything, and a lot of these domains are also have a need for HPC, so they come to us for help. The setups we have are rather modest. Our biggest cluster is 8,500 cores, but we do add a new cluster about every year, and then we discontinue the oldest one. So there's constantly new stuff coming in and new systems to set up. We have about 3 user support people in the team. That's actually going to go down mid-April. So that's going to add a bunch of workload extra, I guess, in my lab until somebody new comes in. And we take care of everything. For a lot of the clusters, we just order the hardware from a company like Dell or HP. We ask them to cable the racks and so on. And from there, we take it. We roll out the systems ourselves. We do the configuration management, the burn-in, testing, everything. We set up the pilot usage, help the users to start running on it. And then, of course, we support them and train them throughout the lifetime of the system. We're also a member of the Flemish Supercomputer Center, it's a virtual center. It's a collaboration between the Flemish universities in terms of HPC, and we also get funding from the Flemish government and so on. So to focus on the user support aspect, so this is the kind of questions I get to deal with every day. You have to resolve all kinds of problems that users come up with, ranging from simple stuff like I'm not able to log in anymore, I lost my private key, or I forgot my password, or how did this work again with this public-private key thing, because sometimes it's a little bit weird for them. My job crashed and please help me, and they don't even mention what the error was or where the job is, and then you have to go. They just assume you know everything for some reason. Sometimes they are surprised that you're able to access their account to help them. So it gets interesting, and then sometimes they claim, something broke, you changed something, I didn't change anything, and you have to fix it. Then, of course, it turns out they did change something that turned out to be the problem. So we answer these questions. Some are very simple to answer, some are very technical. They ask for help with scaling their code, or with just weird issues with the software they're trying to run. A lot of it is also installing the tools they need, the scientific software they need, because a lot of these biologists and chemists, and they didn't get thorough training in computer science, but yet they have to deal with all these modeling tools and so on, and just getting them to work is already a big issue for them. So we help out a lot with that. We also help them to improve their workflow. So sometimes they come to us for help and they say, look, I'm not really happy with how it's working now. Maybe there should be a better way. And sometimes they are just bringing the system down by doing something very stupid. And we go to them and ask them to come in for a meeting, and we help them out doing it the proper way. We also train the users basics of Linux, because sometimes people are not even familiar with Linux yet, and you give them a black window with a terminal, and you tell them not to touch their mouse anymore, and they start panicking. And then, of course, OpenMP, MPI. We do a lot of Python, and we also train our users to use Python in their jobs as glue and for their job scripts and so on. Theoretically, we should also be doing performance analysis and optimization of some of the large applications at our site, and also helping people develop their own scientific software. But in the end, it turns out we just don't have the time for it. All the other stuff is taking just too much time, and we try to help users as best as we can, but really going deep into performance analysis and things like that is just doesn't work out. So one of the big questions we get is installing scientific software. Usually this is by user request. So they have a new version of the software is coming out, and it has certain features or capabilities that they are interested in. So they ask us to update it. Very often it's also new software, something they heard about at a conference, and they want to try it out, but they're not able to figure out how to install it. Or they do, as the instructions of the software say, just do sudo apt-get install. And then they say, oh, I entered my password and it's not working, can you help me? So a lot of the times people hardly have an idea of what they are doing. Typically we install the software on a shared file system that's mounted on all the worker nodes. So we install it once and then it's available everywhere. We do specifically target the installations for each of the architectures of the clusters we have, which makes a lot of sense if you're doing HPC. So we always build from source if we can, even if binaries are available, just so we can use the latest compilers, the latest instructions supported for the architecture, a recent version of MPI, BLAS, LAPACK, and so on. And we highly optimize, of course, for the architecture as well by using the right compiler flags, using recent libraries, and so on. If updates are available for compilers and libraries, like the Intel compilers are typically what we use in Ghent, then about every 6 months we define a new, what we call compiler toolchain, and I'll get back to that, with the latest compilers and update of the libraries in it, and then we rebuild all of the popular software even before users come to us and ask it. So we just want to make sure we're getting the best performance out of the system that we can. Typically, all installations we do stay there during the whole lifetime of the system, so we don't throw away things. If they want to use the modules or the software builds that they were using 2 years ago for their paper, they can still do it while finishing their PhD, as long as the system is there. Of course, if the system is not there, we're not going to keep dragging along all the old software installations anymore. Sometimes we do by request, but they really need to have a good reason. And we also provide module files for all the installations we do. So module files, I'm not sure how many people here are familiar with the concept of environment modules. I guess most people are. Who knows what environment modules are and how to use them? Who has used them before? About half. So environment modules are really the standard way of how scientific software is delivered to users on HPC systems. So we've been doing BOF sessions at supercomputing and ISC on the topic of getting scientific software installed, and then part of the BOF is doing a survey, and the numbers show that over 80% of all HPC clusters use some form of environment modules to deliver the software to their users. So basically what you do is you have a module file that specifies the changes that need to be made to the user environment. So things like updating paths, updating LD library paths, where to find include files, and maybe some environment variables that are really key to the software being used. But you do this in a way that's independent of the actual shell being used. So whether you're using Bash or C shell, you do it in a single file. And then you have this modules tool that interprets the ticker or the Lua depending on which tool you're using, in which the module file is written to really go and change the environment by user request. So this provides an easy interface for the users. They have commands like module avail that they can use to check if a software is available on the system as a module. If they can figure out what they need, they can load the module, typically by specifying the name and the version. They can check which modules are loaded with module list. And they can also roll back, so they can unload modules, which is sometimes interesting. They can clean the whole environment with module purge to start again if they're not happy with their setup and so on. So typically, people include a couple of these module load statements in their job script, and then below that, they go and do the actual computations. So for users, this is easy. They don't really care what's behind it, libraries, compilers, and how everything works, and how the libraries are found, and everything. The executables are just available in your path, and you don't have to specify things full path or figure out where things live. It pretty much just works, or at least that's the intention after they load the module. So the Tcl-based environment module system has been there since 1995 or something. And it's also what most HPC systems are using today, still. Even though it's old, it's not being updated anymore. It's actually broken now if you use the latest Tcl version. If you use Tcl 8.6, it just crashes if you try to install it. So you have to use Tcl 8.5, so slowly that's becoming an issue. And I'm not sure if there's going to be an update to actually fix that. I'm sure people have patches to fix it, left and right, but I haven't seen an official release yet that actually fixes this issue. The good news is that there's actually an alternative, which is, for different reasons, a lot better than the Tcl-based one. Not only because it's not Tcl anymore, there's good reasons to not use Tcl. It's Lua-based. It's actively maintained. It improves the user experience. It has a lot of extra features that are not available in the standard old Tcl-based version. And if I'll have time at the end of the talk, I'll get back to that and do a short demo and show you what it can do on top of the existing tool. It's basically the same interface, but with a lot more features. Okay, so a question we get a lot is, please install whatever software on the HPC from users. So roughly speaking, this accounts for about 25%, probably even more than that, of all of our user tickets. But it does require more than 25% of our time. You have to figure things out, what dependencies are needed, where the software is, how you can install it, how you can test it, make sure everything is there. So this takes a lot of time to get it right. And sometimes we need to get back to the user and say, look, we did the installation, to us it looks okay. Can you please test it, make sure you have input files and check the results and so on. And every now and then they get back to us and say, it just doesn't work, or something is missing, or this is not how it's supposed to work, and so on. So just installing lots of scientific software is a huge time gap. So it's very error prone. You just need to try things, follow the documentation, then figure out it's out of date or incomplete. So lots of trial and error going back and forth. Actually, to get it right and to make sure that it's installed the way it's supposed to be installed and it works the way it's supposed to work is not always easy, because very often you need domain knowledge, which we typically don't have. So we need to get back to the users and ask them to help us. It can be very repetitive and boring because you're trying to figure out compiler issues all the time. I don't think it's boring because you always find dark corners of scientific software and software in general. And it can be very time consuming. It's easy to get lost in this and spend the whole day on installing this simple tool, which I'm sure you're all aware of. Dependency hell is something that pops up, and I'll show some of that in a couple of slides. And sometimes it's simply not worth the effort. Sometimes it's just the user asking, I heard about this tool at the conference and I want to try it. Can you please install it? And then you take the effort, maybe a day to install it. And if you then look at the statistics later of how often the module was used, they load it once or twice and they say, it's not for me. And then you spend the whole day installing the thing. So yeah, this is clearly an issue. So some of the common issues we run into. So it's scientific software. It's written by scientists. They're not software developers, and they don't really have to be. It's not their main interest. A nice quote is, if we knew what we were doing, it wouldn't be called research. So, they of course develop software because they have to, but they don't really care about the software. They care about the science behind it. It's just a tool for them. So they don't care about doing it cleanly or having nice object orientation and they don't really care about that. Very often they don't even care that other people struggle to get it to work. It works on their system, they're happy, and just they throw the tarball out there and say, here, you can use it if you want to. If you're lucky, there's documentation. So lots of this leads to incorrect use of build tools. So they Google for how do I configure something, and the first hit, they pick whatever tool is being used there, and they try to maybe copy-paste the configure script and just adjust it to their needs. Sometimes they use non-standard build tools, so they reinvent the wheel. They just have a bash script to configure, which is just very specific to their tool, and you're just supposed to figure out how it works. Sometimes they use broken ones, and I count CMake as a broken build tool. I don't really like it for several reasons, even though it's still gaining ground and lots of people are picking it up. Build procedure can be incomplete, so there's no configure step. They just have things hard-coded in the make file, and they just expect you to tune the make file to your liking, or there's no install step. They just build things in place, and they have the binary, and just say, okay, here's the binary. You don't really copy it out to somewhere else, and make sure it's nice and clean. They don't really care. Sometimes the installation scripts are interactive, which is just, as a sysadmin, sysops type of guy, this is just really something you don't want to deal with. You don't want to answer the questions over and over again and make sure you get the right builds. Hard-coded parameters I already mentioned. Documentation, lots of this software is open source in one way or another, and then documentation is always an issue. And of course, the dependencies can be a problem as well. So I have two examples of this. So WRF has come up, or WRF has come up before. It's actually a really big application. It's weather modeling software that's one of the big applications on blue waters. So lots of big supercomputers are using this. So who here knows about WRF or has gone through the pleasure of installing it? A couple of people. So in terms of dependencies, it's actually not that bad. You need a couple of libraries like netcdf, which is now split into two libraries, C and Fortran, HDF5, and then Tickle Shell to run the install script, and some JPEG library thing that you also need. So that's pretty okay. It's a handful of dependencies and nothing too crazy. And each of these are pretty easy to install. But still, you have to go through them, maybe make sure they have the recent versions, make sure they are built with the same compilers to make sure everything's compatible and links and works nicely. The way that these people do releases is very weird. So every now and then they have a new version. But then if bugs are reported, they don't do a bug fix release. They just have a website that they update, and they say, literally, open this source file, go to this line, and change it from this to this. So they don't even provide a patch file or anything. They just say, these are the instructions to fix the software. Okay, that's one way of doing it. They have a configure script. So if you unpack the tarball and you go in and you open the README, it says, just run the configure script. You say, okay, I know this, configure dash this prefix, very standard AutoTools thing, and then you figure out it's an interactive script. So it's just something they wrote themselves, and they happen to call it configure. This configure script dumps a configure.wrf file, and it actually tells you afterwards, yeah, go into the file and make sure it's correct, because I may have gotten things wrong, and it does get things wrong. So you have to fix it. So why have a configure script in the first place? And I don't know. They have, after the configure, they tell you to run the compile script, which is just pretty much wrapping around make. So people know make, why try and make them use something else? I'm not sure. It has an option to build in parallel, but if you try it, it doesn't work because they get dependencies wrong in the make file. And it's not hard to fix, but you have to edit the make file to fix the dependencies, and then you can build in parallel. And there's no installation step. They tell you run the compile script, and then there's the binary, just use it. Okay, so it would be really nice if you're able to just install WRF with a single command and not deal with all of this crap. And this is actually one of the things that you can do with EasyBuild, and I hope to give a demo of that actually either in this talk or this afternoon. Another example is Chime. This is in the bioinformatics realm of software, and if you've ever dealt with bioinformatics software, you know this is a whole different league. I think every week each bioinformatician starts a new tool and starts reinventing the wheel. So this is a big mess of things, and there's lots of small tools out there left and right that work a little bit different and do the same thing but better than the others. And it's a huge, huge mess. One of the nice examples here is Chime. It has 59 dependencies. This includes all the optional ones, but still it's pretty big. This is actually the dependency graph. So Chime is actually this thing here at the top. This is the install request you get from a user. This small blob here is the compiler toolchain. So typically you already have this because you're using it for other software as well. And then everything else in between is things you have to make sure that are there, are up to date, are the right version as Chime wants it. So of course this is a nightmare. It uses all kinds of different programming languages. So it has plugins and extensions and tools that calls out to. So you have to make sure they have Haskell support, Java, Python, R, Perl, OCaml, which is just very non-standard and weird to install. And it actually segfaults if you build it with the Intel compilers because they use non-standard C. Big mess. So several of these use a non-standard build procedure, so you have to fix them or figure them out one by one and just slowly get to the top. So this literally took us, with 2 guys, a couple of months, not full time, but it is easily a couple of man weeks to get it installed. And I haven't had the courage yet to actually check if they are using it. And the good news is we did all of this with EasyBuild. So I think we actually did an update of Chime recently. I did an update of Chime recently. And it took me like 2 or 3 days to do the update because everything was there. I just had to check on updates for the dependencies, make small changes left and right, and then just install the whole thing. The Chime support hasn't made it in the latest EasyBuild release yet, but we're working on that. It's just we want to get each of these things right and double check everything before we claim we support it. But in the end, if we do, you will be able to install Chime with a single command and just lots of patience. Let EasyBuild handle everything. So it's pretty clear that there's a big issue here, and this is all of the HPC sites around the world have to deal with this. It's a huge burden. Lots of time is being spent both by the user support teams and also by the researchers, because sometimes they go in and try themselves. They lose lots of time. They can't figure it out. Then they get back to us. Can you please look into installing this? And then they spend time waiting because they want to start playing with these tools, start evaluating them, and so on. Lots of sites quickly figure out that doing this manually is going to drive them nuts. So they start writing scripts of themselves. Typically, one guy in the team is responsible for the scripts. And if he's on holiday, then the installations just have to wait, and so on. So there's very little collaboration among HPC sites, even though they all have the same issue. So this is how the situation was at least a couple of years ago. It's now slowly changing. Of course, there are existing tools out there. Installing software is not a new problem. The package managers have been doing a great job of doing this for system tools and even some scientific software, or at least the supporting tools are pretty easy to install with something like Yum or apt-get, and there's lots of people working hard on packaging and making sure the packages are up to date and so on. There's platform-specific solutions as well, like Homebrew on OS X is really popular and works really well. There's actually a port for Linux as well, Linux Brew. I'm not sure how actively maintained this one is, but there's certainly stuff there, and they really ride on top of Homebrew. There's Portage in Gentoo, which is Gentoo is known for pretty much compiling everything from source as well, so it kind of goes in the direction that we actually need to go. Package Source basically does the same thing, and they support a whole bunch of platforms. It used to be NetBSD, but now they're way beyond that. Every Linux flavor they support. NetBSD, FreeBSD, I think even OS X is there now, and they have tens of thousands of packages. It's really a huge repository. And then more recently, there's Nix and Geeks, which are functional package managers. So it's a new concept, and these guys are doing really well in terms of making sure that the builds you do are totally isolated from the OS, and they make sure that I think they actually use containers to do the builds in, and they just make sure they can reproduce the builds. So Nix actually claims that if you can build a software package on an OS X system, you can just take that recipe and use it on Linux and it'll work. Which is, OS X and Linux are different enough that this is actually a major thing. Now, none of these are actually a good fit for HPC systems and scientific software for a couple of reasons. So typically, most of these don't care about having multiple versions or multiple builds with different compilers side by side. They just say, just bump to the latest version, and this is fine. So if you do a pull request to Homebrew to bump a version, you're literally replacing the version that was there already, and just then you can install the latest version. But installing the old version, you can probably do it, but it's very difficult. And having two versions side by side is just, yeah, they don't really support that. They don't care. Which is, of course, not what you want on HPC systems. There's lots of specific things in scientific software. Because researchers write this stuff, that some of these are not really able to deal with well. Some of the dependency graphs or just the crazy build procedures they have don't really fit well in some of these. And because all of this, and also because most people that write scientific software or care about scientific software are not really familiar with any of these tools, none of these really has a lot of scientific software supported out of the box. You can make it work with a bit of effort, but it's not really there. And especially things like MPI or even supporting different compilers like GCC, Intel, PGI, and so on is an issue. So this was the situation we were in back in 2009, basically when our first cluster became into production and we started getting installation requests from users. And I wasn't there yet back then, but our technical lead, Steen, quickly figured out that this is going to be a huge issue. So he was basically by himself then. There was a manager, and there were two technical people, but the other guy quickly left. So he was pretty much on his own to support the systems and keep them running. And he was getting these installation requests, and yeah, it was never going to work out. So the first thing he actually tried was, for a couple of tools, is to write spec files. So he could generate RPMs himself for scientific software and just roll it out like together with all of the system tools. But then he quickly realized that spec files are just not ready for scientific software. As soon as you go too far beyond configure, make, install, yeah, you just have to fiddle around too much, and there's lots of copy pasting, and especially because lots of these software get updates quite frequently, and you want to be on top of the latest versions, it was going to be an issue. So after he got frustrated enough, he just said, okay, I'll have to figure out something myself. And he started, like many other sites, doing some in-house scripting in Python, figuring out a way to deal with this, and actually generating module files alongside the installations, making sure things were in sync, and so on. Back then, when I entered the team in late 2010, early 2011, it was a big mess. Just like any in-house scripting written by one guy, it actually took me weeks to figure out just what it was doing, let alone how it was working. So it was a big mess, but it was slowly being cleaned up by me, and also we had a couple of summer interns that basically threw the whole thing upside down, redesigned it, and actually took the time to look at functionally how things should fit together and how it would be nice, and then they spent the time on redesigning it in a couple of weeks, which this was something we just didn't have the time for ourselves. And some mid-2012, we were happy enough with how it was working and how stable it was that we actually started looking into releasing it into the wild as open source. Our first intention with this was to get feedback from the community. Maybe someone said, oh, what you guys are doing is stupid, this issue has been solved 10 years ago. It's been around there for long enough. Just use this tool and you'll be happy. This didn't happen, and actually quite quickly people were learning about EasyBuild. We started making some noise, making presentations, and organizing these BOF sessions at supercomputing, and people got interested, and actually a community started evolving, and they started actively contributing and actually asking for features and helping out with features, bug fixes, and so on. So by now we have about a new release every 6 to 8 weeks. Depends a little bit. The latest one was actually done over the weekend before coming here. Today we support over 850 different software packages. Lots of these are easy libraries and tools that you need to build everything else, but we also have big scientific applications, some of like OpenFOAM, WRF, NAMD, CP2K. I'm mentioning the ones here that can take you half a day to get it to install or to update. And we have very good documentation as well. So we had someone coming in doing contract work to kick off or at least merge all of our internal documentation to the Read the Docs platform as well. So we're really happy with that, and of course we're making sure this is being maintained. So very quick highlights of the features. So what can EasyBuild do for you? It supports fully autonomously building and installing scientific software. It takes care of all the dependencies as well. If you tell it to do so, it generates the module files. It keeps a thorough log of the build, and so you can get back to it later and figure out what it was doing if something was wrong for whatever reason. We archive the build specifications, and I'll get back to that. You can configure it, so we try and do as less hard coding as we can in terms of how it works and where stuff goes, like installation prefix and even things like the name of the modules it generates. It is all stuff you can configure. You can extend it, so you can add support for more software, more compilers. Basically, at runtime, you just give it a plugin and it picks it up whenever it needs to. So it does need to be part of the mainline version. You can maintain your own stuff on the side if you want to. We're really serious about testing, so every time we do a release, we actually rebuild everything we support, which is by now something like 5,000 builds, just to make sure we don't break things. It's really actively developed, and it really, especially today, it's a collaboration between HPC science around the world. That's a really nice turnout. So in terms of terminology, and I'll be probably mentioning these in the rest of the talk and this afternoon as well. So there's the EasyBuild framework, which is really the core, the heart of EasyBuild, which has all the supporting functionality. Simple things like unpacking tarballs, applying patch files is all supported in there. So you just call out to a function, and it makes sure everything is okay. And then we have these easy blocks, which are basically Python modules. You can look at them as Python scripts, which can be a plugin to the framework. And each of these easy blocks implements some install procedure. This can be a generic install procedure like configure, make install, or something very specific to the software like WRF. You have to call this interactive configure thing and then patch the configure.war file and so on. Then we have easy config files, which are just build specifications. They're basically simple text files that tell EasyBuild, please build this software with this version, use these compilers and libraries, use these configure options, and so on. And then the compiler toolchains I've already mentioned. These are just a combination of typically C, C++, Fortran compilers, together with a bunch of libraries for MPI, BLAS, LAPACK. So what do you need? What does EasyBuild need in terms of system requirements? So it's targeted towards Linux x86 clusters, pretty much. It used to be somewhat specific to Red Hat-based systems because that was what we are using in-house. But with the community growing, it also works on Debian, Ubuntu, you name it. It probably pretty much works there. It kind of works on OS X, but it's not a main target platform. It's not HPC, so you will certainly run into issues quickly there if you try it. There's no Windows support, and we'll probably not look into that. This may sound like a joke, but for researchers that use Windows on their laptop or their workstation, it may be important to let them install scientific software there first and then get back to you with an install request. But yeah, it's not something we will be spending time on, at least. With the latest release, we actually have stable support for installing software on Cray systems as well, on top of the Cray stack. And I'll show some of that this afternoon, how that works, with a lot of help from the people from CSCS here in Lugano. Support for Linux on power systems is being looked into by some people at Texas University. So next to Linux, you need Python 2.something, 2.6 or more recent. We're not Python 3 compatible yet because Python 2 is not going to disappear in the next 5 years at least. So it's not something we're really going to spend a lot of time on for now. And you need a modules tool, so it really integrates with the modules tool as well. So of course we support the standard Tcl/C environment modules. So the latest stable release 3.2.10. There's an important bug fix in there that actually I did. It was being triggered by EasyBuild, so you really need this version for it to work properly. Or you can use a recent version of LMOD. It needs 5.6.3, but this is actually, in terms of LMOD, this is ancient. It's like over 6 months old, and LMOD is already way past that. Okay, so I want to do a quick demo here. Let's hope the Wi-Fi still works. So what I'm going to show you is how EasyBuild works. So we have the main EB command, and we specify the name of an easyconfig file it knows about. So this actually will tell EasyBuild to build the HPL linpack benchmark, the latest version 2.1, and to use this compiler toolchain, which we call FOSS. So FOSS is for free and open source software. It's because all the components in it are open source software, GCC, OpenMPI, Laypack, OpenBLAST, and so on. So if you start from scratch, EasyBuild will actually take care of all of this. So it will start with bin utils and GCC, OpenMPI on top of that, and then the other libraries on top of that. And then when everything is there, it will build linpack on top of this toolchain as well. And it will generate module files for each of these. So let me see if I can give a quick demo of this. Okay, I'm still logged in. So all you need to do to make this work is basically this. So we can ask EasyBuild what it's going to do or which dependencies it's going to install with dry run, and I'll get back to this afternoon. So it's just showing here that all of the X marks, everything is there up until the toolchain, FOSS. And then it tells us that HPL itself, so this module is actually still missing. There's no X here. So if you don't do the dry run, it will actually go ahead and install it. So it starts unpacking things, making sure it has the source files. It configures the build. For HPL, there's probably not much to configure other than maybe patching the make file because they hard code, whatever. Then it's actually running make here. This is a single core system, so it takes a while. It runs a small test, I think. It does it uses the standard input file for XHPL, which is some very small matrix. But at least it makes sure that the thing runs. And then it copies out the binary, does some sanity checking and so on, cleans up after itself, and we're pretty much done. And then if you check with module avail, you now have this XHPL, the HPL module, which you can load. And then you have the XHPL binary available in a prefix that is specific to the version, this particular version of the software, this toolchain, because it was built with that and so on. And this is the same interface you get for WRF or CP2K. It's pretty much only this. I'll show a little bit more demo this afternoon, but I'm running short on time, so let me continue. So this is what the output looks like. So it tells you at least which step it is in. It gives you the location of a log file, so if it crashes or something doesn't work, you can actually dive in and figure out what it was doing, in which environment it was running, what command it was running, and why it thinks it was supposed to run that, and so on. If things go well, it will complete and it will clean up after itself, and then you will get the module that it says here. So for each of the installations, it actually runs through this install procedure over and over again. So it starts by parsing the easyconfig file to figure out what it needs to build and install. It will make sure it has the source files. It will set up the environment, unpack. If there are any patch files to be applied, it will apply them automatically. It will configure, build, test, install. If there are any extensions like extra Python modules or Perl modules, it will also take care of that. It will do a sanity check, which is things like, is the binary there, is the library there, just to make sure that sometimes the make just exits with 0, but it actually crashed internally because of the way the make file was written. So just checking exit code is not good enough. You have to really do a sanity check afterwards. If it's happy with the sanity check, it will continue, clean up, generate the environment module, maybe fiddle with permissions if it was told to. We also have actually support to generate RPMs from the installation we do. So you can just do the installation with EasyBuild and then obtain an RPM in the end. And lots of people start actually relying on this to roll out the installations to their systems. And then if it knows about any test cases, it will do as the user would do, which is loading the module and then run the test case, just to make sure that it actually works. So this is the generic install procedure. None of these, in the framework at least, are specific. So the configure step is actually empty. It will crash if you run it. But you have to, so each of these steps are overridden in custom EasyBlocks. So if you use the configure make install EasyBlock, then the configure step will be defined as run configure -- prefix with the install location. Build will be defined as make -j as many cores as are available, and so on. So you get a lot of flexibility. You can redefine each of these steps if you need to, but typically you only need to care about configure, build, test, and install. Everything else is pretty much taken care of for you. So to clarify a couple of things, because I get questions on what EasyBuild exactly is a lot. So it's not just another build tool like make or CMake or anything like that. It doesn't replace these. If the software you're installing has in the documentation, please run CMake and then make install afterwards, that's exactly what EasyBuild is doing. So you don't have to rewrite the build procedures. The scientific software developers don't have to change their software at all. We just wrap around whatever they tell us to do, and it goes and does it. So it's not our intention to replace CMake or any of that. It's also not a replacement for something like Yum or apt-get, because these people are doing a really great job of packaging software, of dealing with dependencies and everything like that. But getting scientific software in that whole framework is probably going to be a lot of effort, and it's probably not going to work out. So it's more like something you should use on the side, on top of the packages, or at least some of the packages that are in the US. It's also not a magic solution, so sometimes it crashes, sometimes things don't work, depending on the system you're on, and I'll get back to that in the afternoon. So what EasyBuild can be and what it sometimes already is, at least according to me, it's a proper way of installing scientific software. It keeps you sane. It's also a uniform interface, so you're using the eb command all the time, really independent of which software you're using or which compiler or MPI you're even using. You don't really care how to deal with an MPI library. EasyBuild knows, or you can tell it if it doesn't know yet. It's a huge time saver. So you just hit eb, please install Wharf version 3.6.1 with the latest Intel compilers, and then you go for a coffee or you go for lunch, and if you get back, all the modules are there. So you can actually get real work done rather than fighting make files or figuring out compiler errors. Of course, somebody always has to figure out the issues first. So if there's a new version of Wharf, maybe there needs to be an update to the EasyBlock for Wharf in EasyBuild. But somebody does that once, applies that fix or change centrally, and then everybody can just install WRF with a single command. That's the whole idea. We build on top of each other's work. It's also a way to provide a consistent software stack to your users. So because it's fully automated and EasyBuild generates the modules, it will always do the same thing. It will follow the naming scheme you tell it to use. Rather than if Jack or John is doing it, you may get something slightly different because they have different preferences. So you just implement your site policy and EasyBuild sticks to it. I also see it as an expert system for software installation. So there's lots of small tricks and checks in there, or like patches for make files, or making sure that it uses -01 rather than -02 because there's no issues. All of this knowledge is in there. And if you're building a software package out of the box because it's just supported, you don't really care what's behind it, because usually it's pretty okay and it performs well. We've shown EasyBuild to application experts at some sites. There was one guy that was the application expert for CP2K, and he was saying, why would I ever use this? I know how CP2K works, I know how to build it, I know how to test it. I'm fine, I don't really need this. And then I was showing him, look, installing CP2K 2.5 is very easy. You just hit this, let it run, it takes a couple of minutes, and then it's there, so you don't have to do the manual steps. He says, yeah, sure, but CP2K is 2.6 now, so I need the latest version. I say, okay, try software version 2.6. Let it run, and it goes. Okay, that was easy. And then he actually started benchmarking his own builds as an expert compared to the EasyBuild builds, and the EasyBuild builds were faster. And then he realized, okay, maybe I should really pay attention and see what this is doing that I am not doing. somebody put that knowledge in there, but it was there. And I don't even know what's behind it. I just install it, and it performs really well. It's also a platform to collaborate with other sites, because none of the HPC sites is on their own on this. Everybody has the same issue. Everybody's installing these big applications and trying to get them right and trying to get them to perform well. And we're all facing the same issues over and over again. So it's good to collaborate rather than each reinventing the wheel by ourselves. It can also be a tool to empower users. So especially in Ghent and the other Flemish sites, we actually see users picking up EasyBuild themselves, trying out new software versions because it's dead easy to install it and you don't need any admin rights at all. They can just do it in their own directories on top of the modules that are available centrally. They just try new software versions, try and fiddle with it, and if they're happy with it, they actually give us the easy config files and say, please install this centrally so everybody else can use it. So they're actually taking away some of our work, which is good, because then we can help the other people who are struggling. Very quickly, some statistics. So the latest version has, the code base is getting pretty big. It's about 25,000 lines of Python. If you count the library we build on top of that support logging of the command lines and doing the configuration and also doing the actual logging of the build procedure, it's another 5,000 lines of code. We have a lot of tests. So in total, it's over 42,000 lines of code. So it's getting pretty big, but we try very hard not to do copy-pasting left and right, and we refactor all the time to keep the framework pretty clean. And it's getting better and better, but I hear from people that it's reasonably easy to dive in, figure out what it's doing, and make small changes by yourself. We have about 200 easy blocks now. Most of these are software specific. So like we have an easy block for WRF, we have an easy block for CP2K, and so on. We have about 30 generic easy blocks which actually support over 80% of the software we support. So there's lots of configure, make, install, CMake, make, install. Installing Python modules is the same thing over and over again, so we reuse these generic easy blocks for this. Lots of software we support today out of the box. There's lots of bioinformatics software. That's not a surprise because there's lots of tools out there. But also lots of the people that picked up EasyBuild early are in the bioinformatics sites. So they were just struggling all the time with all these install requests. They started looking for a solution, and they bumped into EasyBuild, and then now lots of them are active contributors in the community. So we get updates for bioinformatics software all the time, and reasonably quickly. In the release, we ship over 5,000 easy config files, which we should look at these as examples rather than something that you should maybe use standard out of the box, even though they typically work. But it's probably worthwhile to at least check what they are doing and check if they are using the configure options that you expect, and so on. And they're very easy to change. The community is growing, so of course we're using it in Ghent University and the other Flemish institutions, thanks to the collaboration. Jülich was one of the big sites that picked it up pretty early. They've been actively contributing even in the framework and really deep down in the core of EasyBuild. They've been helping out as well. They're now using it on their new big production Eureka x86 cluster. So that's the only way they install scientific software or supporting tools for their users. It's all through EasyBuild. And even their module tree, it's a hierarchical module tree, and I'll try and get back to some of that this afternoon. Everything is done through EasyBuild. At CSCS here in Lugano, they've also picked up EasyBuild, even on their Cray systems, and they've actively helped out with getting the whole Cray thing working, and I'll show this afternoon why this was not trivial. But now it's stable with the latest release, so they can easily install software for their users, both on their Cray systems and on their standard clusters. Lots of small sites using it throughout Europe. Big sites in the US like Stanford and Colorado are both using it and contributing back, and even down to New Zealand, Australia, recently also Cuba, people have picked it up. Also, commercial companies like Bayer in Germany is using it to roll out their bioinformatics stuff. There's other companies as well. Some people are here, but they asked me not to mention them. So if you count the stars, you can maybe figure it out. It's big companies in different domains. So it's nice that they are also picking it up and that they are not afraid to use the GPL licensed open source software. So this was a little bit of a concern that we had, but apparently it's not a big issue for companies if there's enough value in the tool. So by numbers, don't want to go into much detail here. So we do frequent conf calls. We have an active mailing list where stuff is being posted every day. We've been doing these BOF sessions at ISC and SC on getting scientific software installed. So this is not specific to EasyBuild. We actually have had some of our competing tools talk there as well. And the LMOD guy has been giving presentations there. And we do a survey that takes about half of the session. We do hackathons every now and then. And actually this week and at CSCS on Thursday, Friday, there will be an EasyBuild hackathon as well to further look into the Cray support and so on. Lots of pull requests that we're getting and that are getting merged. Lots of open ones as well. So because this is part of our day job, and developing EasyBuild is actually not my main task. Supporting the users is. So all the contributions we get, we at least I do my best to process them and get them merged. But it's not always easy because people open a pull request and then don't have time to look back anymore. And, it requires a bit of pushing left and right, but we're dealing with it. The community is growing fast. This is the subscribers to the mailing list over time since we open sourced it. So in the beginning it was kind of slow because we weren't making a lot of noise, but then like this nudge here is supercomputing, I guess. Yeah, or at least the result of supercomputing. It's quickly going up, so we get new subscribers almost every day. People asking questions, small issues with the setup or things they don't really understand yet. And from there, they actually roll into actively helping. So this is the contributions we've been getting. This is unique contributors. So every bump is a new person actively changing something in EasyBuild. Lots of these are easy config files because these are pretty easy to write yourself and to contribute them back. So over 80 people have contributed back one or more easy config files. And even in the core of EasyBuild and the easy blocks, we're getting lots of contributions. So over 40 people now, which is pretty impressive. So it's not a single guy tool anymore. It's way beyond that. There are some recent projects that are similar to EasyBuild. SPAC is the main one, which is being used at Lawrence Livermore. The other one, so this one is pretty much dead because the guy at Oak Ridge stopped working there. It's not being actively maintained. And this is supposed to be open source, and they're trying to push it out. But I doubt it's actually going to be useful for other people. This SPAC thing is interesting, and we've been talking with Todd Gamblin behind this quite a lot as well. We have a paper that discusses EasyBuild and LMOD, so you can just find it here at this link on modern scientific software management. So this was done together with the people in Jülich and the LMOD maintainer. Some future work, which I'm not going to get into now, and lots of links to click if you're interested. I have some more slides on LMOD, but maybe we can do this afternoon. If people want to have EasyBuild stickers, so if you're convinced, and lots of laptops are empty here, if you want stickers, you can grab them here and back there as well. And I'm happy to take questions if there's time. Yes. Okay. Yeah, so one of the things we support is, so the EasyBuild generates a module file at the end which sets up the environment. You can tell EasyBuild to include extra things in the module file. You can just say this parameter set it to this value and so on. You have full freedom there. Yeah. Yes. It's actually in Python. So just set HTTP proxy, and then EasyBuild uses the right library to deal with that. Yeah. Okay, there will be another session this afternoon with more hands-on demos and some getting started information. Thank you.